Hey students, good evening and welcome to our next live YouTube session by Quant Masters. That is the 20th session that we're having, 20th live interactive session that we're having with you guys to go through all the kind of questions, all the kind of problems that we can generally expect when it comes down to TCS NQT or even TCS Digital or even with Infosys. Now, before we begin, as always, I just want to confirm if you're all able to hear me properly and see the screen. Any one of you can just send a text in the live chat so that we can get to know, and we'll begin right away. So, as usual, I hope I'm audible and I hope the screen is visible for everyone. Yes, perfect. So, in our last session, if you guys remember, we went through this particular problem called word search. We have solved it in C++, but due to time constraints, we went way over the limit of yesterday's time, and we had to debug a couple of things. We didn't do that yesterday. Let's continue that today because we have to solve it in Java as well as Python. Now, for those who are attending this as our first session, I'll just give you the logic in just a very quick manner. You have a grid of words. You have a grid of words which is m cross n or something like this. And in this grid of words, you're going to have to search a particular word. And when you search that particular word, it could be in any order. It could be in horizontal and vertical, horizontal, vertical, any such combination. Like for example, if I want to search this particular word, pig for instance, it is like this. So we can make horizontal and vertical movements, but we won't be able to make any other movements. That's the whole scenario. We shouldn't be able to make any other movements. Now, we had solved this in Java, and this is the problem that we came up with. If I compile this, we got this particular error where it says bad operands for binary operator. It says that logical OR operator is a binary operator. For that, first type is int, second type is int. We're not supposed to perform it like this. There are multiple ways you can solve it from. I'll give you the simplest and easiest ways. Since both types are int, let us not do OR itself. Let us do plus instead. Let us not worry about doing OR at all. Let's directly go ahead and do plus. When we work through plus here instead of OR, the result can be 0, 1, 2, 3, any of these values. So since result can be more than 0 as well, in our scenario, we shouldn't consider that if the result is 1 only, then we can say it is found. No. Even if the result is greater than 1, like 2, 3 or anything, we can say it is found. So I can give a condition here that if result is greater than 0, we say it is found. So all that we are doing here is, to avoid all of this, we are just using plus. That's the entire scenario. Now, one more thing that we can do here, one more little thing that we can basically do here is, instead of performing all this substring, now I just want to point this out. Please remember, if you are modifying a string a lot of times, if you are modifying strings so many times, you're going to be performing more operations than required. So whenever you modify a string, at the start of the function, you can convert that string and store it in a string builder. Because when you use a string builder, they are mutable. So a couple of things that we need to know when it comes to Java, that is, strings are, as we have learned in our sessions earlier as well, strings are immutable. That means you cannot change it. Whereas a string builder is mutable. That means you can change the position. So you can use set char at with a string builder, but we can't do it with a string. So since we have already chosen as strings, if one simple condition is convert that string to string builder. Take a string builder, let's say SB equals, take that string called word. We can convert each one of them to string builder and try. That is one way to do this. Or even here, each grid of I, whatever you have, each grid of I you can convert to string builder here and try. But since I've already worked through strings, I'll also show you guys how to, let's say, if you're doing one modification, like let's say just one small operation or something like that, it doesn't really make sense to convert to string builder and everything if you're doing only one operation. So in that cases, in those scenarios, I'll just show you guys how you can change a character in a string. How we can change a particular character in a string. To change a character in a string, we're going to create our own function. We're going to call it static because it should be accessible with basically without any object. So return type is string because it's supposed to change a character and return string. So I'm going to call this as change character. Yep. So what and all do I need to change a character? I need the string. I need the starting index where I'm supposed to change. Int index where I'm supposed to change a character, and char the new character which I'm supposed to update it with. So these are the three things which we need. The string in which I'm supposed to change a character, the index in which we are supposed to change a character, and the new character itself which we are supposed to add. Once we do this, since I cannot perform any modification in a string, I need to convert my string to a character array. I'm going to take string to character array. I basically need to convert our string, whatever we have, to a character array. Our string name is str. I'm going to use str dot to character array. We are converting it into a character array, and let's store it as character array equals, let's say, string to character array. Now, when I convert it to a character array, now I can change any index because it's an array, right? In an array, I can go to the index where I'm supposed to change. This is the index that I'm supposed to change. I'm supposed to update it with new character. So array of that index I'll update with new character. Now I need to return this back. When I return it back, I need to convert it back to string and return it. So to make sure that we are converting it to string, I can return new string of array. This character array, whatever we have just converted it to a string now and returning. So if you want to make a change in a string, you basically have to do this because strings are immutable. Strings are basically unchangeable. You cannot make any changes in string whatsoever. Since strings are unchangeable, you're going to have to use, let's say, string stored in a character, converted to character array. In the character array, make the change, then return the new string. So here we're going to call that function. If you guys remember, I'm supposed to change whatever is at index j to hash. So I'm going to call this function. Our function is called change char, and it will return back the string. That string, whatever is returned back, I will store it in grid of I. Grid of I equals change char. Which character am I changing? In my string. Which string? The string in which I'm changing the character is grid of I. That is the string, because grid is an array of string, grid of I is an individual string. In that string, I need to change for the index j, and I need to replace it with hash. That's it. Now same thing here in the next line. What I need to do in the next case, what I need to do is change it back to temp as my character. That's it. This is my entire change that I need to do. If we do this, our logic should work. Our program should execute. Let's see if we get any errors. Okay, I've missed out a semicolon here. Let's add that. Let's try now. Okay, one more semicolon. I've missed out this as well. So let's try now. Now again, one more semicolon I've missed out here. Let's even add that. Now let's give this a try. Alright, and I think I've made a couple of typos here. Let's also change that. Seems like one after the other we're getting a lot of errors. That's alright. Now, since we're done with this, let's execute this code. Let's see if it works. I'm going to give a 3x3 matrix. I'll give A, B, C, D, E, F, G, H, I. And what I want to search here is A, D, G, H, I, F, C, B, E. If you guys observe, A and then D and then G and then H and I and then F and then C and then B and then E. We're taking all characters together in the horizontal and vertical order the way it is. We are able to find it. If I try the same, let's say 3 and 3, no, I'll take A, B, C, D, E, F, G, H, I. Now, if I take A, D, I, A, D, I are not together, it says not found. That's it. That was the only change that we needed to do for this particular program. And we were able to solve the same program even in Java. Now, final thing, very simple and easy thing. We're just going to convert it to Python. Final, easy and simple thing. Now, what is the first thing we are supposed to read? Rows and columns. So let's read rows and columns. So I'll take rows equals int input, because row and column are integer values. Columns equals int of input. Done. After we read rows and columns, we then need to read an array of strings. Remember, if you want to create an array of strings, you basically need to use a list. And in this list, each element is another string. So I'm going to use how many how many strings will be there? If you guys observe here, as many number of rows are there, there will be so many strings. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 rows. That means there are 8 strings here. Same way here, I'll use for I in range of 0, rows. So I'm going through all rows over here. So for each row, what are we going to do? For each row, we're going to go through and read a string. After reading a string, we have to enter the string as a part of grid. So I'm just going to use grid.append of, let's say, what's our input statement. That's it. Whatever input string is there, we're going to add it to the end of grid. After this, we're going to need to read one more element, that is our word. So I'm going to use word equals input. It's a string. Now, if you really want to see them, I'll just show here print of grid, word. I'm printing both of these. Let's see if it works. We're going to interpret this. We're going to run this. Here, let's say we'll take, let's say 3 cross 3 again. Let's take A, B. Okay, I've made one mistake here. Let's try again. Let's take 3 cross 3. That means 3 rows and 3 columns. Since it is 3 rows and 3 columns, each row should have 3 characters each. It's a m cross n, right? So I'll take A, B, C, D, E, F, G, H, I, and I'll take the next string as something like A, B, C, D, E, F. I'm getting the grid as a list of strings, or as an array of strings, however you want to call. And then I'm getting a string. So we are able to read the input. After reading the input, what are we supposed to do next? We're supposed to call traverse function by sending all of these. Let's call traverse function. Now I have to define the traverse function first. Let's define traverse function here. Now, whatever we are sending from here, we're reading exactly with the same words. Let's update it here. Now, what are we going to do in traverse function? Let's take a look at this. So the first thing we're going to do in traverse function is to check if the length of the word is greater than rows multiplied by columns. Let's say this. If length of our word is greater than rows multiplied by columns. In that case, we don't need to do anything. In such a scenario, we can just print something like not found. And after printing not found, we can directly return. Nothing else to be done. Again, no semicolon required. I'm just going to skip it. I have one question. You are not given any condition for column. Yes, we have not given any condition for column here. I'll tell you why exactly we have done that. Because we're going to be giving a condition for columns here in this scenario. Because if you remember this particular code, we use this way to go through each element. We use this for loop to go through each element of the second string. Each element of string. And how do we know the length of all strings? All strings length or column. That is where we use them. So I hope the idea is clear. Now, in traverse simple logic, I need to go through for I in range of 0, rows for each row. Then for j in range of 0, columns for each column, I need to check if grid of I of j. Here in our case, we need to check if grid of I of j, every single element, is equal to word of 0. That's what we're going to check. If grid of I of j is equal to word of 0, then we will call our check word function. If this is the case, only then we will call our check word function. That is, what is that function? The function is right here. I'm just gonna copy this condition as it is. If grid of I of j is word of 0, that means we have found the first character. That means we need to search around it. If we have found the first character, we need to search around it. If second character h is there anywhere, and then from there we need to search for the next one. So we need to do a recursive function for this. So we're gonna call this function, and we're gonna see if the resulting value is greater than 0. If the resulting value is greater than 0, then I'm gonna print found, and I will just return. If it is not found at all, if it exits this for loop successfully without finding any element, then I will just print not found at the end. That's it. That's all we're gonna do. This will be our traverse function. So there's no need for us to change anything else. That's basically it. Now we're gonna have to do this word search function. To do this word search function, I'm gonna copy this exact thing, whatever we have here, and I'm gonna paste it above this. Okay, very sorry guys, I did not even notice this. Thanks for noticing that. So let's go ahead and give this a try. So we're gonna define word search function, but here when we define word search function, we need to specify here, instead of 0, we need to read it as a variable. We cannot read it as 0, of course. We need to read it as a variable because we're gonna keep calling it recursively again and again. I'll call this as index. That is how we're gonna read it. That is what we are reading here also. We'll take it as index. If you guys remember, it's index. Now, what do we do here? Let's copy this entire logic. I'm gonna copy this entire logic here. I'm gonna paste it here. This is what we are supposed to work through. Now, let me use one less tab space. Perfect. Now, first thing, if index is equal to word length as in we are going to use length of word. I have one question. Why are we sending 0? Okay. See, if you remember the last session, first thing I'm sending is I'm finding the first character. Since I know that I found first character, I'm telling that the index found is 0. So when it goes ahead to the function, we will search next to this element the next index. We will search index plus 1 here. Wherever we found it here and here, right? So when here and here it is found, next time it performs recursive search. Next time it performs recursive search for the next character, it should find its next index. That is why we send the value of index every time as next element. But first case, initially, since we have found first element, we're going to say we found index 0. Then when you find the next element, you say that I found index plus 1. Then if you found the next element again, to the next recursion, you're going to say I found index plus 1. Since it receives that it's found E, it's going to search for the next index. Perfect. Glad that you got it. Now, let's take this scenario. If index is equal to word length of word, we're going to return 1, indicating that it is found. Otherwise, we have this condition which is supposed to be in OR. We just need to change it to words because in Python, it's completely in words here. If we cross the boundary, we say that we can't continue further, we have to return. Now, on the other hand, we have this particular if condition and this else condition. Let's take a look at this. Now, in this, I don't need to check like if grid of I dot character at j. It's just grid of I of j. That's it. Nothing else. Even here, it's just word of index. I can directly access indices here. No need to worry about it. Even here, I don't have to use character at j. I can just use grid of I of j. Will be stored in. No need to specify it as character. Just in a variable called temp. Then, since I'm changing grid of I of j to hash, instead of doing all of this, we can directly write grid of I of j is equal to hash. That's it. Then I don't need to write int here, and wherever there is, okay, let's leave it as it is. Plus means it's going to return a value greater than 0 also. Since it may return a value greater than 0, we have to use the condition greater than 0 here. That's one change we have done. Let us keep it. We don't need to change it. Why change something which works? Now let's take the next scenario. Again, here we're gonna have to use, instead of hash, we're gonna need to change it to temp. We're gonna store temp back. Now after that, we're gonna return the result. Else we're gonna return 0. That's it. This is our entire logic. Now we're not sure if this works. Let's see if this works. Let's give this a run. Now it says one error. Okay, if length is greater than rows into columns. I haven't used column here. Let's do that. Let's update. Let's see if we go wrong anywhere. Nowhere. So I'll give 3 and 3. A, B, C, D, E, F, G, H, I, and I'm gonna use the same thing. A, D, G, H, I, F, C, B, E. It should say it's found. But there's one problem here. If you guys observe this, it says string does not support this. String does not support this item. I cannot store a hash directly as it is within grid of I of j in Python. So that means I need to do something else, right? I need to basically figure out a different way. Here's how we do this. Remember, I cannot directly say grid of I of j equals some particular value. I'll give you guys the example. What we need to do here is convert this list over to a string. In that string, whatever the grid of I is, remember guys, I'll just point out here. Grid of I is an element of a list. I cannot just say within element of a list, within this case, make it to hash or something. I cannot do that. I need to take what is in grid of I, this particular thing, as a separate string. I need to store it as a separate string. In that string, I should replace it, the index j with hash. After replacing it, I need to return it back here. There are multiple ways to do it. I'm going to do it in one of the simplest and easiest ways here. Now, first thing I'm going to do here is grid of I, whatever grid of I is there, that is our string, right? So that string, I'm going to store it in a temporary list. I'm going to store it in a temporary list where I'll convert the grid of I, whatever is there, into a list. Now, don't worry, you'll get to understand this very, very quickly, very, very easily. Now, what I'm doing here is, here it is. Let's say we have a string like hello. H is found. I need to replace H by hash. Since I want to replace H by hash, I'm taking this string which is available within a list, mind you. Please note it's within a list. I'm taking this and creating a separate list out of it. When I create a separate list out of it, I'll get H, E, L, L, O. This is what I'll get. In this, I'm going to take whatever index I want, 0, 1, 2, 3 or 4, whichever index I want. I'm going to go to that particular index. After going to that particular index, I'm going to replace it with hash. After that, I will store it back as a string, back in grid of I. That's what I'm going to do. It's going to become hash ELLO. So we've already converted it to list as temp underscore list. Now, in temp underscore list of j is equal to hash. We're replacing that. And after doing this, we need to store it back in grid of I. Now, how will I store it back in grid of I? I need to convert it back to like string, right? So to convert it back to string, all I need to do is dot join of temp underscore list. That's it. So not dot, I need to add a string. Yeah. So I'm adding a string and joining temp list. That's it. This will join whatever is there in the temp list and make it a string by the end. And that string, whatever I have, I'm just storing it here. That's all we need to do. Grid of I is equal to that temp list that we have joined. So same thing I'm going to write even here. In this case, I'm just going to replace it with temp now. Since it's an element within a list, we get this error that the string doesn't support this item assignment directly. So for that, it's a string. For that purpose, this is what we're doing. Now let's see if it works. Let's try this out. Okay, it's running. I'll give 3 and 3, A, B, C, D, E, F, G, H, I. We'll give the same input. AD GHIFCBE. This is what we have. It says it is found. Let's give one more example. Let's see if it works. Word search. We'll give 3 and 3. I'll take ABCGEFGHI. Now, if I give AI, it's not present. It says not found. That's it. This is our simple word search program when it comes down to Python. Now, I just want to point out one important thing to everyone. In our 20, this is our 20th running session. In our entire playlist of hourly sessions that we had, this is our 20th session where we first started with a program on Lapindrome. We've learned how to figure out anagrams with a Lapindrome program in C++, Java and Python, all three. Then we figured out a particular problem where we tried to convert a T9 keyboard input into its all permutations to show all permutations of what could be printed. Here we did something like use a queue to perform backtracking and everything. This is something which we have done, or sorry, not backtracking, breadth first search is what we have done here. Then we try to find out the nth number of a series involving a combination of prime numbers as well as Fibonacci numbers in the most efficient way using dynamic programming. We have done that. Again, all in C++, Java and Python. Then we have tried to find out a hollow diamond pyramid problem like this, given any string, where it should continue the string in every single line. After that, we went through to our next problem, which was, okay, that was hollow diamond. Then we went to find peak element, where you need to find an element which should be strictly greater than its next elements. Next elements as in the elements next to it. Along with this, we try to do this in the best time complexity, that is big O of log n. At Varun and Swami's question, I'll just tell you in just a few minutes. Don't worry. Alright. Along with this, after find peak, we went through binary addition as strings. Again, in the most efficient way. Then we try to find out how we can figure out if a number can be reversed without overflowing, given that a number greater than its range can never be stored. Followed by that, we learned how to add two strings as an integer. Then we try to convert Roman numerals into integers using the most efficient searching technique of hashing, where it only takes one operation to perform search. Then, followed by this, we went ahead to search for valid parenthesis. That is the flooding problem. After flooding problem, we went through to our string rotation using KMP algorithm, which is the most efficient method to work through. Once we were done with that, we immediately went for, that was checking rotation. Then we went for our current problem, which is word search. So all of these problems we have done till now. This is what we have done in our 20 hours of sessions, nearly 20 hours of sessions of live YouTube training for digital Infosys preparations, digital preparations as well as NQT. So with this, our live YouTube sessions will come to an end with this. Our live YouTube technical coding sessions will come to an end with this. So we've had a really fantastic 20 continuous days of time where we have gone through these late evening or late night sessions, some may call, on a constant basis, and we've had a very good turnout from you guys who are always in live chat, very encouraging and always interested to learn in all the programming languages that we were working through. So thanks a lot for joining in. But this is not the end of it, because we still have a lot of programs, we still have a lot of concepts, we still have more advanced concepts, more complicated stuff, more okay, send all. I'll do that. I'll just send everything in one link. So we still are not done with it. So we still have a lot of things. There could be some other questions which can be asked on trees. Some questions could be asked on linked lists. You never know, because you never know what question will be exactly asked. There could be some questions asked on permutations and combinations. There are tens and tens and hundreds of different types of questions that can be asked. So followed by this, from the next session, that is from tomorrow, we will be going through our live session for Quant Masters students specifically. We are going to be switching over to live sessions here. This is digital 20 hours of sessions. So with this, we'll be moving over within our next session to live Quant Masters sessions that we are having as usual. For those who haven't joined yet, I think you guys can definitely check the description if you want to go through more of these videos which can help you with programming or competitive coding. For those who are already joined or going through this, you guys can get the information on how to join by tomorrow. So we'll be continuing ahead from tomorrow. But from tomorrow, it's going to be for our Quantmasters registered students, where we'll be going through a lot more programs. So I don't think there has been any other, let's say, YouTube or any other, let's say, YouTube series, or I'm not sure. I don't know if there's been anything else, as far as I know, which has gone through such detailed technical training in all languages by explaining the logic and then solving it in C++, Java, and Python by specifying the best time efficient program with knowing the time complexity and everything. So I hope you guys had a really fun time going through this. I hope you guys had a really fun time going through all these programs. I hope you guys had a good time through this. So you guys can just send one text in live chat if you found it helpful, if you found it good enough, or whatever it may be, if you find it useful, or if you found that, hey, you know what, I think it may help. Whatever you may have felt through this entire set of nearly 20 hours of live sessions that we have gone through, you guys can just send one message in live chat. It's going to be always helpful to see. It's going to be always nice to see your response by the end. So with this, we're going to be ending our live sessions on YouTube. Probably over time, we're going to be continuing ahead. So I'm sending the link. We're sending the link, not to worry. All right, we're sending the link right away. So I hope you guys had a really fun time with this. For those who are attending these sessions or attending later on within these sessions, you guys can subscribe, check out through our previous videos of this playlist. It's in an entire playlist along with aptitude videos as well for this. For those who have attended from the first session, who have been very interactive throughout nearly 20 hours of sessions, it's been a lot of fun to go through these programs with you guys. It's been a lot of fun to have you be interactive through YouTube live sessions. It was a really fun time. So good luck with your interviews. I hope these will help you out. If you do want to go through more programs, do check out our channel description, and get in touch with us. We'll definitely be going through more programs from tomorrow, same time, for our registered students. You can go through that as well. So until then, until we come up to YouTube for live sessions or live videos again, have a good time. Good luck with your interviews. We'll catch up in the next time, guys. Take care.